Good day everyone, we are group 3. Today we'll be presenting data on wastewater treatment process which we obtained from UPC Chemicals Malaysia Sdn Bhd. There are 4 of us in the group, myself Singing, followed by Normalisa, Maisara and Junhao. For presentation outline, we'll start with company background and objectives, followed by our CRIS-DM approach. We'll be analyzing and interpreting our data using Tableau, and we'll finish our presentation by sharing our reflection of the project. Starting with company background. UPC Technology Corporation is founded in 1976 in Taiwan. UPC is the world's largest phthalic anhydride and plasticizer manufacturer. A side note, phthalic anhydride is used in plastic industry for the synthesis of plastic resins, while for plasticizer it is also used in plastic industry as an additive to increase the processability, extensibility, and flexibility of the plastic. UPC has 8 sales and manufacturing centers, 1 in Taiwan, 6 in China, and 1 in Malaysia. And Malaysia plant is their first UPC plant in Southeast Asia, operates since 2016. As UPC is a chemical manufacturer, they will be using a lot of chemicals in their process. Therefore, before releasing wastewater into the river or ocean, they need to make sure that it will not cause pollution to the environment. So, UPC has a wastewater treatment plant. There, parameters will be set and monitored to ensure the quality of wastewater. Parameters like temperature, pH value, BOD, COD, and so on will be monitored. For the objective of our project, firstly, we want to make sure the quality of wastewater discharge is able to meet the environmental regulations set by the government. Second, we want to predict and forecast the amount of wastewater being discharged into the river. Thirdly, we want to use analytic tools like Tableau to reduce data analysis time. Fourth, we want to develop a dashboard for effective decision making for both operator and management.
Next, I will present on the CRIS-DM approach and process. CRIS-DM, which stands for Cross-Industry Standard Process for Data Mining, is an industry proven for directing the data mining operation. CRIS-DM can be described as the methodology which details every typical phase of the project. So there are 6 phases in the CRIS-DM, starting from the business understanding, data understanding, data preparation, modeling, evaluation, and deployment. I will explain on the first 2, which are business understanding and the data understanding. So the first one is business understanding. So in this phase, it is important to understand the business operation to gain the better understanding, and this will help us to precisely specify the current challenges, evaluate these challenges, and recommend the solution. UPC Chemicals Sdn Bhd is the largest manufacturer of the plasticizers in the world. Thus, in the conjunction with the production process, UPC Chemicals Sdn Bhd need to ensure the WTP cleans the sewage and water so that they can be returned to the environment. So our objective of this project, the water release must comply with the Malaysian Environmental Quality, which is standard B, before being released to the environment. And the success criteria, the management able to use the dashboard to monitor and operate the wastewater treatment effectively. So the next is we need to review the current situation in terms of the inventory resources, requirement, assumption, constraint, risk and contingencies, cost and benefit. So this table depicts the current situation of the WTP. So there are 2 main process plant, which is PAPL and PL2, that will release the wastewater into the wastewater treatment plant on the daily basis. So the requirement is to meet the criteria as the per DOE, and we assume the lab instrument used to collect the raw data is in a good condition, field data is accurate. So our constraint is there might be a possible human error when we record the data, and the risk is the lab instrument failure. We are unable to test the water quality, and also the reporting and errors of the system due to human error. So as the contingency, we have the backup data from time to time in case of the data is corrupted. So by having this dashboard, it is to ease the day-to-day operation monitoring and decision making of height management, so that the WTP is able to work in optimum condition and treated water release into the river meet the standard. So finally, create a project plan. It is important to understand the whole process of the WTP to get a better understanding. So this figure shows the general process involved in the WTP. So it involves a few stages such as the screening, pumping, the aeration, the settling, disinfection, and the sludge treatment. Is data understanding. So in this phase, the data will be gathered, described, and explored to make sure it fits the business objective. So currently, in terms of the data availability, the data is recorded in the hard copy and is keying into the Excel sheet by the operator on the daily basis. So the soft copy also available in the Excel format, and the parameters must meet the range as per the DOE requirement. So in terms of frequency, there are 44 data sample was tested on the daily basis. So the data that we use for this project started from the January 2019 until May 2022. So these are example of the data taken on the daily basis. Next, I will pass to my team on the data analysis.
Hi everyone, I will continuing on with data preparation. In preparing the data, there are a couple of steps that have been taken. So we begin with data selection. The existing plant data was recorded on paper by hand on daily basis by the field operator. The data were then transferred from paper to Excel file. For this project, we have gotten the real data set, which is from 2019 to 2022, which we will then be used to construct an interactive dashboard in Tableau. To focus on our current project objectives, we only select data which are related to our project. Next is data cleaning. Since the data were written and recorded manually by the field operator, in data cleaning process, we had to fill in some missing informations, finding or deleting some of the outliers, and also rectifying inconsistency. Unclean data might lead to uncertainty and in the mining process, which will lead to erroneous results. Therefore, this cleaning procedure is considered one of the most essential in data preparation. Next is data integration. Data integration is the process where we merge data from the overall data. We notice that by integrating the data, we have reduced and eliminated redundancies and inconsistency in this collection. These are new variables that we have from merging the data in data integration. One is the USB average, which we have calculated from the average of USB 1 and USB 2. Next is percentage of USB COD removal. This is the difference between the chemical oxygen demand, which is COD, value in inlet and outlet of USB. This is the parameter. This is like a parameter that acts as indicator to monitor the COD removal efficiency of USB. Next is the percentage of oxidation removal. It's almost the same as the first one, which is the percentage of UASB. But for percentage of oxidation removal, it calculates the difference between the COD value with inlet and outlet of oxidation. Next is data reduction. Data reduction is the last step in preparing the data. We went through data reduction, which we have minimizes the quantity of the data set, but still we managed to maintain its originality and its integrity. Therefore, it is safe to say that the valid data reduction will provide identical or almost identical analytical outcomes. In a simple way to explain this, in this case, that we have already reduced a couple of variables by taking only, for example, for OXY4 COD instead of going through the parameters of OXY1, 2, and 3, which are actually the same process but just before OXY4. Next. Alright, now we proceed with evaluation. In evaluation, the last results that we have gotten were interpreted and analyzed in order to know whether if the project objectives has been attained. The evaluation of this project was done through hypothesis testing. This method is to determine if the dataset that we have contains meaningful results or not. The main reason for hypothesis testing is to determine if the probability that a population parameter is true. In this case, we have kept the main variables that needed to be tested in carrying out these hypotheses. So first is the EQ tank to downstream COD. This is the parameter or volume of wastewater prior to entering the wastewater treatment system, which will then be flown to downstream. EQ tank is where the wastewater treatment process receives all the wastewater from the plant. This COD is like the concentration of pollutant in water. Next is the UASB1 and UASB2 COD. UASB is the heart of the wastewater treatment process. This is one of the main processes to remove the COD out from the water system. Next is oxidation COD. Oxidation is another most important process in removing COD, like UASB and UASB1 and 2. Next is final discharge COD. This is the amount of COD that has been discharged into the river after going through the whole wastewater treatment process, COD removal process. And last is the total treated water discharged into river. So this is where we calculated the total amount of treated water that has been discharged into the river. Thank you.
Hi, I'm going to present about data visualization and result interpretation. In this project, we have created 3 dashboards. One dashboard is for the operator and 2 dashboards for the manager. The dashboard that we created for the operator, the data shown will show a short period of time only, which is year 2022 only. In this slide, I'm going to present about the dashboard that we created for the operator. In the first graph that we see, is the X point COD concentration. X point is the final discharge point for wastewater treatment plant, and the COD is the contaminant level in the water discharge. So from this graph, we observe that there is a slightly higher spike reading in the COD, which is 84 mg per liter of water discharge into the river on 25th of January 2022. So overall quality of water discharge into the river in the year 2022 in terms of COD had met the requirement set by the Department of Environment, which is 200 mg per liter. So the second graph shown in the dashboard for the operator is a UASB and oxidation COD removal percentage. In another word, is a UASB and oxidation performance. UASB and oxidation is the key unit operation in the wastewater treatment plant. It plays an important role to remove the COD from the water itself. So we observe from this graph, both of these UASB and oxidation shows good performance in this year 2022, where both of these unit operation have the COD removal rate up to 80% consistently. We had created 2 dashboards for manager. In this slide, I'm going to present the first dashboard that we created for the manager. The dashboard that we created for the manager will show the overall performance of a wastewater treatment plant since it operated, which is the year 2020. Manager will be able to monitor the overall plant performance and important trends from this dashboard that we created. In this first dashboard, the first graph shows 2 important information, which is the total COD sent into the wastewater treatment plant and the total COD discharged into the river. Ideally, a well-working wastewater treatment plant will show long green bar and a short orange bar. It means that the wastewater treatment plant receives high concentration of COD and discharge low concentration of COD. We can observe from the first graph, it shows increasing trend of high COD level discharge into the river since year 2020 third quarter, and it reached the peak at year 2021 first quarter. This is due to large amount of water was sent into wastewater treatment plant because during that time is the monsoon season and the wastewater treatment plant unable to perform as it should. So we can observe another repeating trend, which is in the year of 2021 fourth quarter, where this is also the monsoon season. A large amount of rainwater was sent into the wastewater treatment plant, and the wastewater treatment plant unable to remove the COD effectively, resulting in the higher COD number discharged into the river. In the second graph is for the manager to monitor the total treated water discharged into the river. We can observe in the year 2021, the first quarter, wastewater treatment plant discharged a total amount of 6,237 metric tons of treated water into the river, which is higher than usual. This is due to because of monsoon season at the east coast of Malaysia, and we will expect high rainfall during that period of time. This is a second dashboard that we created for the manager. In this second dashboard, we show the overall performance of the two main unit operation in the wastewater treatment plant, which is USB and oxidation. These two units is the heart of the wastewater treatment plant and is responsible to remove most of the COD from the water. Observe that both USB and oxidation shows reduced in performance during the year 2020 fourth quarter. Performance of USB reduced from 60% to 25%, and the performance of oxidation reduced from 100% to 80%. Whereas in the year of 2021 fourth quarter, observed there is another reduce in performance on USB from 80% to 60%, while performance of oxidation reduced from 100% to 80%. This is mainly due to high rainfall. Thank you.
Let's move on to the reflection of the project. There is a reading error occur while we are trying to analyze our data obtained from Tableau. We can look at the first graph on top. There's a red horizontal straight line above indicating our COD limit at 200 mg per liter. As this red line acts as our limit line, there shouldn't be any blue line touch or exceed this line. If we do so, it means that our wastewater treatment plant have some issue and we need to take note on it. But when we look at the reading when the blue point touched the red line, the reading at the blue point is only 84 mg per liter, which means in fact it actually haven't touched that 200 mg per liter limit yet. But from this graph, it seems like it already touched our limit. So we found out that actually it's because the range we use at both axes are different. The scale on the left-hand side, we are using the maximum range of 200, while the scale on the right-hand side, we are using the maximum range of 80. Therefore, when we change the maximum range of both axes to 200 mg per liter, we can see right now that no more blue line touching the red line, which is actually giving us the correct result. So this gives us a lesson that when we have one line acting as a limit or reference line, we should change the range at both axes to the same range in order to avoid any misinterpretation of the result. While performing this project, it really gives us the insight of how important it is to use analytic tool, especially while we are dealing with a huge amount of data, because data digitalizations allowed better data management as we're able to visualize our data. And while we are trying to reduce down our data into the smallest useful form, it actually helps us to understand our data better and improve decision making. These are the lessons we learn. That's all for our presentation today. Thanks for your time. Now we are open for questions to the floor.